maybe good evening, yes, depending on when you're watching this. Welcome to lesson 13. So in our previous lesson then we had an introduction to programming languages, yes? So we looked at a variety of common programming languages, what they might be used for, whether they're compiled or whether they're interpreted, and kind of what their application is, whether they're used for more system-heavy coding, whether it's more in the business world, maybe it's more for scripting. Yeah, so that was the last lesson, Programming Languages 1. If you haven't had a chance to watch the video that's recommended in question 4 about an advantage, disadvantage of assembly language, then please do try to watch that video. Yes, it is quite a useful video. Here it is. So they've got the C code here. And then they've got the assembly language here. This title is actually wrong, comparing C to machine language. This is not machine language, yes? This is assembly language, yes? So it's comparing C to assembly language. But still, a very, very worthwhile video if you do get the opportunity to watch that. We finished the last lesson by looking at Java, and then we tried to work through this code snippet, which we're going to revisit in this lesson. It's important in this lesson. So let's crack on then. Lesson 13. The start of this lesson, I want to talk about loops. Loops are fundamental in many programs. All programs except the very most basic program will have some sort of loop to it. Yes. We saw some examples of loops here. A while loop, a for loop, and a do while loop. We will revisit those in a minute. Yeah. So here we've got an explanation of each of the different types of loops. So a for loop, we initialize our variable, we test our condition. If our condition is true, we execute the code block, we increment our counter, and we go through as many times as we need to. For a while loop here, we have a condition at the top. If the condition is met, we execute our code block. And then we test the condition again. If the condition is not met, we continue through the code. For a do while loop, we actually do the code block first, and then we test the condition after we've done the code block. So a slight difference here between do while and while. Yeah, and then if the condition is not met, we exit. If the condition is met, we do it a second time and a third time, and so on. So, we've got some sentences here. One of these loops is used in situations when we don't know how many times we need to do something. You need to decide, is that about a for loop, is that about a while loop, or is that about a do while loop? We have another situation. One of these loops is used in situations when we don't know how many times we need to do something, but we know we need to do it at least once. Yeah, so is that a for loop, a while loop, or a do while loop? And then we have a third situation, used in situations when we know exactly how many times we need to do something. Yeah? So you can pause the video while you think about this, and then resume once you think you know the answer. So 1, 2, 3, A, B, C, what do you think? Okay, go. Right, okay, so used in situations when we don't know how many times we need to do something. Well, that's a while loop here. Maybe we don't do it at all, in which case we just exit down here. Maybe we do it once, maybe we do it 10,000 times, yes? But we come in here, we test the condition. Maybe we don't do it at all, maybe we do it 10,000 times. So this is a while loop. Used in situations we don't know how many times we need to do something, but we know we need to do it at least once. So that's here. So we do the code block first. That's a do while loop. Then we test the condition. And then we might go back and do it a second time. Or we might just exit out into regular program control flow. And here, used in situations when we know exactly how many times we need to do something. Well, that's a for loop. Yeah. We know we need to do it 10 times, so let's enter, let's do it 10 times, and then let's exit. Let's have a look at some of these some of these loops as real code. So this is a real example. These are all written in C, by the way. So for int I equals 1, so int means integer, I equals 1, so we start with a value of 1. Semicolon. Now this is our condition. I is less than or equal to 10. So while this condition is true, we're going to do this code block. And each time we go round it, I equals I plus 1. Okay, so we're going to increment this. We're going to add 1 to I each time we do this. And do something. This is our code block here, do something. So nice and straightforward. This syntax is very common to other programming languages as well, not just C. This is our while loop, so we need to initialize initialize I, sorry, and then here is our test. Here's our condition. While I is less than or equal to 10, so the same condition. Do something. We have to increment I ourselves in the code block here. Yeah. So again, nice and straightforward, I think. And this is a do while block. So again, we initialize I. We have the do statement first. We do something. We increment I, and then this is our test here. Yeah. So this code block here happens at least once, whereas this code block here might not happen at all. Yeah, that's an important difference here. This code block here, this do something, might never happen. If this condition is never true, this code block will never happen. If this condition is never true, this will be done at least once, because we do this code block before we get to the conditional statement. So that's an important distinction between while, a while loop, and a do while loop. Yeah? Let's try to make this distinction even clearer. Okay, so we've got 3 scenarios here. Which loop do you think we need to use in each of these scenarios? Okay, so scenario A, we want to read lines of data from a file of unknown length. Are we going to use a for loop, a while loop, or a do while loop? We want to find a number divisible exactly by 5. For loop, while loop, or do while loop. Or C, we want to generate 5 random numbers. For loop, a while loop, or a do while loop. Okay, take a minute to think, pause the video, and when you're ready to check, unpause, resume, and we will check together. Right, okay, well, welcome back. So this is actually the code from lesson 12. Yes, this is the Java code that we looked at the end of level 12, lesson 12, and we're going to reuse this code because this code coincidentally has an example of a while loop, it has an example of a for loop, and it has an example of a do while loop. So one of the scenarios was reading lines of data from a file. Well, it makes sense to use a while loop to do that. We don't know how many lines there are going to be. There might not be any lines. It might be an empty file. Yeah, so using a while loop makes the most sense for this. And we've got an example here. So we've got this file scores.dat. We're going to load this into this object S. And while we have numbers in that file, we're going to show that number on the screen. Yeah, so I think we can run this. I think I ran this earlier, so I should have it somewhere. Java C.java. Okay, so I'm going to compile it into bytecode. And now I'm going to run it. Right, okay, and here we can see this is task 1, yeah? So the file has 3 numbers, 12, 46, and 92. Let's check this. Aha. So here's the file. This is scores.dat. 12, 46, and 92, and then it meets something that's not a number. Yeah, remember the code, while has next integer, so it's going to continue to loop until it finds something that's not an integer, that's not a number. And this is not a number. String is text, it's not a number. If we take that out, and if we save it, and if we run it again, then we get a much longer list of numbers, yeah? But still, it stops once it gets here, 22.22, because that's not an integer. That's a float or a decimal, depending on which language you're working in. So if we take that out, it should read the whole file. So starting at 12 and finishing at 83. Starting at 12, finishing at 83. Yeah. So this is a good example of a while loop. If the file was empty, we run it again. Then task 1 outputs nothing. Yes, the while loop. This code body just never gets executed because there aren't any integers in that file. Okay, I'll put those numbers back for next time. Yeah. So this is a good example of a while loop. We don't know how many times we need to do it. Maybe we need to do it 0 times. Maybe we need to do it 50,000 times. A while loop is what we need for this. Task 2. So now this time we're going to create a file. Yeah. So randints.txt. So random ints means integers.txt. So we're going to create this file. We've got an object here, random, the name is R. And here for I equals 0, so we start at 0. I is less than limit, so limit is 10. I plus plus. So we're going to do this 10 times. We're going to actually start at 0, so we're going to do this from 0 to 9 inclusive. And we're going to get a random number each time. And we're going to display that number, and we're also going to write that number to this file. Yes, and here we can see 0 to 9. We get some random numbers. Some of them are positive, some of them are negative. They're all very big. And if we do it again, we'll get some different numbers. If we do it again, we'll get some different numbers, and so on and so on. Yeah. So that's a good example of a for loop. We know exactly how many times we want to do it. In the document, I think it's 5 random numbers. Okay, well, actually, okay, well, here we go. Let's change that to 5 then, yeah? So we just want to generate 5 numbers. Let me recompile that. Run it again. Now we just get 5 numbers, yeah? So we know how many numbers, and a for loop is fit for purpose there. Now, what about the last one? Last scenario, we want to find a number that's divisible exactly by 5. So let's have a look at the code. So we've got 2 initializations here. I equals 0, so this is how many times we iterate around the code block. And then I just means integer, and want is my random number divisible by 5, yeah? So we're going to do this. We're going to do this at least once because we might get lucky the first time round, but we're starting from 0. We don't have a number divisible by 5. So we know we need to do this at least one time. So a do while loop is fit for purpose here. And I'm going to use this Java library math.random just to give me a random number. And this maths here, this just makes sure that the number is not huge, that it's not negative. This just makes sure that I get a number between integer 0 and integer 100. Yes, we saw here, these are huge numbers. We don't want huge numbers. We don't want negative numbers. I just want a number between 0 and 100. That's all this maths do. All this maths does. So we're going to do this while iwhat mod. So the modulus of iwhat is not divisible exactly by 5. Yeah. So while we don't, when we divide iwhat by 5, we shouldn't get any remainders. any decimal, any fractions, it should be exactly divisible by 5. And here, so we see the first time we did it, we generated a number of 2. That's not divisible by 5, so we did it again. 61, not divisible by 5. 19, not divisible. All of these not divisible, and then, bingo. 25 is divisible by 5. This took us 9 times. Actually, it took us 10 times because our starting point is 0. So it took us 10 goes before we found a number divisible by 5. If I run it again, it just takes us 5 times before we get a number divisible by 5. Yeah. If we run it again, bingo. Yeah. The first time we run it, we generated a number of 0, and 0 is divisible by 5 exactly. Yeah. So the number of times, wow, here we go. 18 took us 18 times to generate that number. So we don't know how many times we needed to do this, but we know that we needed to do it at least once. Yeah, so a do while loop is exactly what we want for this. Right, okay, so hopefully that's explained the difference between for while and do while loop. Quite some very, very useful loops. They're used everywhere. And it's important that we can get our head around those. Right, moving on. Something else we need to touch on is functions. The building blocks of any good function of any good program is a function. Yes, there are many advantages. They make our code more readable. They avoid us having to rewrite common bits of code. They reduce opportunities for error. We can call them whenever we want. Once we've got a function that works, we can use it as many times as we want at very, very little cost. Yeah. Here we've got an example. This is written in C. I think I've got it here as well. Here it is. Yeah, so we've got a couple of functions here. All this program does. Let me run this program. How do I do that? Okay, so enter a number, 12.12, and then it just gives me the square of that number. Okay, so this is all the program does. It asks me to put in a number, I give it a number, and then it gives me the square of that number. Yeah? So we've got 2 functions at use here. We've got this function, and we've got this function. So scanf is actually a system function. It's part of C. It's included in this header. std standard, I input, O output, .h just means a header. So this is a code header that's very, very common in every C program. This is a system function, and this is a user-defined function. This is a function that we've made, and here is the function itself. Yeah, and they look a little bit different. Now, we can ignore this. This is not very important. This just means give me a floating point number. But this is important here, this ampersand. You'll notice that there's no return value here. This function, scanf, doesn't return anything. We pass it ampersand m. Well, m we know is a float, 0.0. And all this function does is it waits for us to put to enter a number on the keyboard. Yeah, so it scans the keyboard, waiting for us to enter a number. And then it puts that number into here, into this variable called m. Now this ampersand is important, but wait a minute. Then we've got this second function here. N equals square m. So this is our function that we've made. To this function, we are going to pass it a variable. We're going to pass it m, which is what we've put in on the keyboard. And it's going to return us a float, a floating point number, okay? For example, 146.89, yeah? So this is the return value. This is our function, and this is the input to that function. Now, these two are slightly different in that here there's no return value, as we can see. Here there is a return value. And here it uses ampersand m. Let me make it a bit bigger. Yeah? And what this means, we're not just passing, well, we're not passing the value of m, we're passing the location of m as a memory address. Whereas here, we're making a copy of m and we're passing m as a copy into the function. So we're passing it by value, whereas here we're passing it by reference. And these are two big differences when we talk about functions. It's quite difficult to explain. It's quite difficult to get a head around. So I've written this this explanation, which hopefully is a little bit easier for us to process. So here we've got a function. This passes by value. So we pass m as a value. What does that mean? Well, pass by value is where I have some information that you need. Okay, you are the function. So the function needs this information. Maybe the information is a simple URL, yes, google.com. Maybe it's a complete copy of Pride and Prejudice, yeah, from lesson 11. No matter what it is, so this program here, I copy the information onto a piece of paper and I hand that paper to you. Okay, that's what we're doing here. We're passing it a copy of m. We're copying it. So I copy that information onto a piece of paper and I hand it to you. So I pass that paper to the function. Now it's your piece of paper. You're free to do whatever you want with that information, and when you no longer need it, you throw that paper away. Yeah? So it's your copy. It's your copy of the data. You can do whatever you want, and you delete it whenever you want. Yeah? Pass by reference. This is passing by reference here. Pass by reference is when I tell you where my notepad is. Yeah, so I've got a notepad. I'm going to tell you where it is. I'm going to tell you the location of it. I'm going to tell you it's on my desk here. Okay, and that's what this means. I'm not passing m, I'm passing the location of m. So I'm telling you m is on my desk here. You can use it, you can do whatever you want, yeah? My notebook has got lots of things written in it. You can use what's written in it. You can scribble in it. You can scribble in it to your heart's content. When you're done, I know where to find it because I know where I left it. And when you're done with it, I will revisit my notebook and I can see what you have written into it. So this is much more efficient. We're not copying anything. I'm telling you where you can find it, and we're using the same piece of paper. Whereas here, when we pass by value, we're making a copy of it. We're passing you a copy of it. And maybe it's just a simple float, which is whatever, 4 bytes, 6 bytes, 8 bytes wide. Doesn't matter. Maybe it's a 10 megabyte JPEG. Maybe it's a copy of Pride and Prejudice, which is, a megabyte in size. If it is something big that we're passing into a function, to have to copy it is actually quite expensive. It's expensive in terms of size, it's expensive in terms of time, and it's another overhead that we need to deal with. We also need to discard. We need to be careful with that memory when we're done with it. Yeah. So if we can pass by reference, we use the same document all the time. I use it, then you use it. That's much more efficient. And what we can also do when we pass by reference, a function can modify many things. Now, a function can only return one item. Here, n. What if we want a function to do many things? What if we want a function to not just tell us the square, but also tell us the second digit, to also tell us its closest Fibonacci number, to also tell us to also give us the rounded value. Yeah. What if we wanted all of that information from this one function? Well, a function can only return one thing. Yeah. So we're snookered a little bit. But if we pass the location of different variables, then there's no limit to how many variables a function can help us fill in. So we're not constrained in the same way. So pass by value, pass by reference, those are quite difficult concepts to get our head around, and maybe before faculty, it's quite an important thing for us to start getting our head around. I've thought quite hard about how to present this to you because it is quite challenging. Hopefully this has done something to confuse you less, let's say. Google is your friend, of course, if you need more information. This document, this C program is on our course page, and you can play with it to your heart's content. Yes. To get it running, I use clang function. So that creates it. This is on Mac. I don't know where your compiler is, maybe on Windows or Linux, but on Mac, my compiler is called clang. So that gives me an executable called a.out, and then I can execute a.out, and it gives me the program. Yeah. Right. Okay. Well, when you're ready, we'll move on. Last lesson 12, we looked at compilers. We looked at compilation and interpretation and various different languages and whether they are compiled or interpreted. It's something we need to talk about a little bit more. It's quite a key concept, this difference between compilation and interpretation. So I've got another example for us to look at. Most languages, they're either compiled or they're interpreted. You can't choose whether it's compiled or interpreted. It is what it is, and you can't change it. Some languages, in fact, I only know of one. I only know of SQL. It can be both interpreted and it can be both compiled. So SQL is actually quite a nice example for us to explore the difference between an interpreted language and a compiled language. Let's have a look at this. Where is it? Query. Right, okay, well here I've got a database query. This is from a film store. And all the query does is it shows us some customer information from customers who rented some Hindi war films, not in China, from male customers. PG just means good for children, parental guidance, and they rented it during this date. Okay, so this query we can put into MySQL, and it will run, and it takes 0.14 seconds to run. Okay, so that's how long it took this computer to interpret this code. So it needs to check the syntax before it can even start retrieving data. Yeah, so it needs to make sure that it's a properly formed SQL query before it can start hunting for data. And then it hunted for data, and it returned us these two answers: Elmer Nor and Justin Nor, both men who both rented these films in these dates. And it took us 0.14 seconds. So this is an example of interpretation. Yes, the computer went through this statement line by line, trying to understand it, and then it set about retrieving the data. Okay, so 2 rows, 0.14 seconds. Very good. Now, SQL can actually be used in a compiled form. So we can compile this query. So let's do that. So I'm going to compile it as a procedure. Okay, done. Yeah. Took 0.03 seconds to actually create that procedure. And by create procedure, what I mean is convert it from SQL into machine code. And then what I'm going to do, I'm going to run that executable. Yeah, I'm going to call that procedure, which is what I did here. Call get special customers. The same answers. Elmin Nyo, Justin Nyo. So the same result set and just 0.03 seconds. Yeah. So here's the example of interpretation. Took us 0.14 seconds. Then we created the procedure. We compiled it. The compilation took 0.03 seconds. Very, very quick compilation. And then to actually run the compiled version took just 0.03 seconds again. Yeah. Oh, wow. 0.0 seconds. Yeah. So compilation is much, much faster than interpretation because it doesn't need to parse the statement. It already understands it. It already has it in machine code. So that's quite a useful, I think it's quite a useful demonstration of the difference between interpretation and compilation. SQL is one of the very few languages that can be both compiled and interpreted, so it's quite a useful example. Right, now, there are some differences, yes, between compiled code and interpreted code. So I want you to do this, and then I want us to check. So which of these hides the code from the user, from the customer? Is it compiled code or is it interpreted code? Which of these allows us to see the code? When we interpret it, can we see the code? When we compile it, can we see the code? Okay, so which of these is about compiled code or interpreted code? And so on and so on. All right, so take some time, pause the video, and come back to it when you think you've got some answers, and I'll talk you through these. Then. Right, okay, so compiled code hides the code. We can't see what's inside the executable. Yeah? I can't see what's inside this procedure. I can't see what's inside this executable. But I can see the interpreted version. I can see the raw SQL. Yeah? So with compiled code, it hides the code. Maybe that's a good thing, maybe it's a bad thing. With interpreted code, we can see what's going on. Yeah, we can see the query. We can see what tables it's using. We can see what the criteria is. When we call the procedure, we can't see any of that. Yeah. So again, maybe these are good things, maybe these are bad things, maybe they're both. It protects my intellectual property. Well, compiled code probably protects my intellectual property. If I want to sell this to somebody, I don't want them to see the code. If they can see it, they can copy it, they can use it for free. I want to be able to give somebody this, and they can't see inside it, because what's inside it is valuable. It's taken me, it's taken Microsoft a lot of time, a lot of energy, a lot of money. Yeah, so compiled code protects your intellectual property. Interpreted code doesn't protect your intellectual property. You can see what's going on, you can copy it very easily, you can modify it very, very easily. Compiled code checks all of your execution paths. That's what a compiler does. Interpreted code only checks the paths that you've gone down. If you're happy with it going down this way, but when you give it to your customer, they go down this way and there's a problem, then your program will explode. Your customer will not be very happy. We have seen interpreted code takes longer to run. Compiled code is faster because compiled code is machine code, it's ones and zeros. Compiled code is more secure? Maybe not, because you can't see inside compiled code, so you don't know whether it's secure. So maybe interpreted code is more secure because you can see inside it. You can see if it's stealing your passwords or if it's scanning your hard disk for whatever. Yeah. So maybe compiled code is actually less secure. It's easy to make changes to. Interpreted code is very easy to make changes to. You can see it. Yeah. Compiled code, it's not difficult to make changes to. It's impossible to make changes to. Yeah. So we have these differences between compiled code and interpreted code that again are quite useful for us to start becoming better acquainted with before we get to faculty. Right, well guys, we've touched on a lot today. If you need to revisit some of this, watch this video again, maybe slow it down. The code to all of these exercises is on our course page. So feel free to play about with it on your computer. Yes. And of course, Google is your friend if you need more help. All right, guys. Well, the next lesson is the practice test. See you then. Bye bye.